Alright guys, today we're going to be graphing quadratic functions. I'm going to start with the quadratic parent function, which is this one right here, y equals x squared, where the x is our input, the y is our output. So let's say that I have a table to calculate my answers here, and I start with 0. If I plug in a 0 here, that would be y equals 0 squared. I'm sorry guys, I know my zeros look like 6s. I can't fix that. So 0 squared is 0. So my input, my x is 0, my y is 0. That would be this point right here. If I plug in a 1, 1 squared is 1. If I plug in a 2, 2 squared is 4. If I plug in a 3, 3 squared is 9. Well, guess what? If I plug in a -1, -1 squared is going to be positive 1. -2 squared is going to be positive 4, and -3 squared is going to be positive 9. That's how it becomes symmetrical, meaning one side looks exactly the same as the other side. It is a reflection. It's called axis of symmetry. That's the line that cuts the parabola in half. So you just look at the value where it crosses the x-axis. It crosses at 0. So that's why my axis of symmetry here is x equals 0. It's going to be this one right here. The vertex is the very bottom or very top where the parabola changes direction. So here the parabola is going down, then it gets to the vertex, and then it comes back up. That's going to be called a minimum. Here, the domain from left to right, the parabola is opening forever and ever to the left, forever and ever to the right. That's why it's negative to positive infinity. We can also say all real numbers, and that's what this R represents, all real numbers. Range is bottom to top. How low does this graph go? Since it's our y values, you pay attention to the y values only. And it goes all the way down to 0, but then it goes up. It never goes past the 0, so that's why it's y is greater than or equal to 0, or 0 to positive infinity because it's going up. Again, that vertex is the lowest point in the parabola. That's why it's called a minimum. And then the y-intercept is where it crosses the y-axis, because this is touching at the origin. Our x-intercept and our y-intercept are going to be the same. Also guys, x-intercepts are also called roots, also called zeros, are also called solutions. And sorry I said that backwards, but my pen is not working, so I'm trying to write as best as I can. Alright, the vertex form, very important guys. The A is going to give us a lot of information. The number inside the parentheses is the H, going to give us a lot of information, and so is the K. Very, very important to identify which is which and what information comes from where. So this is my H, comes from this number, opposite sign, and it tells me if it's going to move left or right. Then the number in the back here is my K. That's going to be the y coordinate of the vertex, and it's going to tell me if I move up or down. If it's adding, it moves up. If it's subtracting, it moves down, and so on. Just make sure you come back and read this. And then if the number in front of the parentheses, RA, is a positive number, it's going to make a positive parabola that opens up like this, and the vertex then is going to be at the bottom, so it's going to be a minimum. But if the A is a negative number, then it's going to make a negative parabola that opens down, and now the vertex is at the very top, so it's called a maximum. Also, the number A, or whatever is in place of A, which is in front of the parentheses, greater than 1, makes a narrow parabola or a vertical stretch, meaning it gets skinnier. If it is a fraction between 0 and 1, then it widens the parabola, also called a vertical compression. Alright, so here's our first example. We're going to get our information from in here. This is our H. This is our K. Okay, so what does it tell us? H tells me that my parabola is going to move to the left 1. That means I'm going to put -1. It's also going to tell me that I'm going to move down 4. So it's going to move the whole origin of the whole vertex down 4. So I'm going to end up at -1, -4. The axis of symmetry is the same value as the x coordinate there. The domain is always going to be all real numbers. Sorry for that funny looking R. I'm trying to make a funny looking R, but it's even funnier than it should be. The range, since it's opening up, it's going to be y is greater than, and always the same as the y value in our vertex. Because it is a positive parabola, because there's nothing in front of the parentheses here. So it's just positive or positive line. Think of it that way. Then it's going to be a minimum, just like our parent function. And then let's see where our x-intercepts cross. So we usually start at 0, 0, but because of that -1 inside, or +1 is it? Let me zoom out so I can see it. Because of that +1, I'm moving to the left 1, and then the -4 is going to move down 1, 4. So 1, 2, 3, 4. So my vertex is going to be down here. But the points are pretty much the same. 1 squared would be 1, 1. 2 would be 2, 4. And then 3 would be 9. So from 4 we go up 5. So around here, something like this. And I'm just going by the equation, moving it up, down, left, or right. So then my y-intercept looks like it's at 0, -3. And you can always check yourself with the Decimals Online Graphing Calculator. My x-intercept there is at -3 here. Or my x-intercept is crossing at -3, 0, and 1, 0. Okay, so x-intercepts are right here. Alright, I think that's all the info we got. Let's go to the next one. Okay. So the h, or the number inside the parentheses, is a -1, so it's going to be positive. And then there's a +1 on the side, so +4. Axis of symmetry is going to be x value, so x equals 1. Domain is going to be 99.9% of the time all real numbers, so I'm just going to put all real numbers. And then my range is going to be y, and because of this negative over here, it's going to open down, so then y is going to be less than or equal to, and the same value as we're going to have there, which is 4, so 4. It's always going to be the y value of your vertex. Alright, and because it's going to be opening downward, then now we're going to have a max, and then we'll look at the x and y-intercept after we graph it. Okay, so we are going to the right 1 because of the -1 inside the parentheses, and up 4. 1, 2, 3, 4. Now this parabola is not opening up, it's opening down, so I'm going to go down. But because I have a 1/4 in front of it, I can actually go down one, just like I would, but I would go down on 1/4 over. So really that doesn't go down a 1 until I go 4 over. Or what would make it go? I think it's 4. 1, 2, 3, 4. No. What would make this thing go 2? Okay, I know a point is there. What would make the whole thing go to 0? If I had a -4 in the middle inside, I mean a -4 in front of the whole thing, then the +4 would be. So what would make it go -4? I think it's a 5. 5 minus 1 is 4. 4 squared is 16. 16 times 1/4. Yeah, so it's a 5. So we can always check it in the graphing calculator, guys. Okay, so it would be the 5 would make it go to 0 here. And then it's symmetrical, so over here should be at the -4 because that's 4 to the right and 4 to the right from the, from the vertex. Alright, so our y-intercept there, actually to calculate y-intercept, you can use, what I did is I put a 0 in place of x. So 0 minus 1 is -1, -1 squared is still -1, and -1/4 times -1 is +1/4. Excuse me, no. not negative 1. That would be negative 1 squared is positive 1. Positive 1 times negative 1/4 is negative 1/4 plus 4 is 3.75. So that would be our x-intercept here would be 3.75. I'm sorry guys, I cannot write with this stupid pen. The x-intercept is going to be at negative 4, 0 and positive 5, 0. Okay, so again, you can always check yourself with the graphing calculator. You can also make yourself a little table, and I would plug in numbers that for sure I could get whole numbers. So I plugged in a 5, and that would give me a 0. I think if I plug in a 3, I get a number. 3 minus 1 is 2. 2 squared is 4. 4 times negative 1/4 would be negative 1, so that would be a plus 3. So 2 would give me a 3. And I think if I plug in a negative 2, would also give me, anyways guys, sorry. You can always do it by hand or use a graphic calculator. And I think that's all the examples I have. Oh, one more. My vertex here is going to be positive 2 and 1. So those comes from here and here. Okay, then my axis of symmetry is always the x value of the vertex, so 2. Sorry guys, I cannot make a better 2. My domain is all real numbers. My range is y is greater than, because it's positive, or equal to the y coordinate of the vertex, so 1. We're back to a positive parabola, so we're going to have a minimum for our vertex. Oh, and actually I'm supposed to be, oh, never mind. The y-intercept, we'll figure it out right now. Actually, y-intercept I can figure out just by plugging in a 0 here for x. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. So that's going to be 0, 9. Okay. Ugh, that's supposed to be a 9, guys. Sorry. I cannot write with this pen. Okay. So my vertex is at 2, 1. So that's going to be here. My y-intercept right now is going to be at 0, 9. And then since I know my axis of symmetry cuts a parabola in half, so if my vertex is here and I have a point 2 to the right and up 9, then I'm going to have 2 to the left and up 9, and 2 to the right up 9 is also going to be a point. So just because I know axis of symmetry, parabola has symmetry. And my x-intercept is no real solution. Let me see if I can type it, because this won't let me write. No real solutions, meaning there's no x-intercept. Maybe I should try and type instead, since this was so horrible to write. So no real solutions. So it doesn't cross the x-axis, no real solution, and that's it. If you have any questions, let me know. As you could tell, this graph is actually more narrow, and that's because there's a 2 in the front, meaning everything doubled. So it changed twice as fast. So if I would plug in, instead of going up 1 over 1, it would go up to the right 1 and up 2. And it would, instead of going 2 to the right and up 4, it would go 2 to the right and up 8. So it changes really quick because of the 2 in the front, which makes it more narrow.